dear students. So here I am your Arka sir. So I have come with a fresh and new episode on JEE NEET special. Okay. So I already uploaded some videos on this topic. The MCQ I am solving. Okay, in my each episode. So if you can watch that serially from episode number 1 to the current episode, you will understand the whole concept of the topic as well as a huge number of MCQ you can solve yourself. Okay, with me. Okay, in my channel. Okay, so it is absolutely free for all of you. So you only have to be patient and you have to understand the topic clearly, and also you have to solve all the problems. Okay, all the questions along with the numeric problem as well as the conceptual questions along with me in my channel. So if you can do that patiently, I am very sure that you can get rid of all of your problems and also you can appear in the examination with full confidence. So without further delay, let us move today's episode, and also I would like to request you to subscribe my channel and share it among your friend circles and known circles so that they can also get benefit from it. Okay, now let us now move to the problem number 1 of today's episode. So a wire connected in the left gap of a meter bridge. So actually we are solving the problem from Wheatstone Bridge meter bridge. Okay, like that. So we are a wire is connected in the left gap of a meter bridge. Okay, balance a 10 ohm resistance in the right gap of a point which divides the bridge wire in the ratio of 3:2. If the length of the wire is 1 meter, the length of 1 ohm wire will be, okay, 4 options are given. Clear? So here what is that? What do we know? R by S is equal to what? 3/2. Clear? And S is equal to what? How much? 10 ohms. Clear? So that means R is equal to 3/2. 3/2 into S is equal to 3/2 into what? 10. So that means what? 15 ohms. Clear? R by S is equal to 3/2. Why 3/2? Because the ratio is given 3:2. Clear? So R by S is equal to 3/2. So R is equal to 3/2 into S. So the value of S is 10. So S is equal to 15 ohm. Clear? So up to this it is clear to you. Okay. Now what happened? One of the resistance. Okay, the length of the wire. Okay, the length of 1 ohm wire. Length of 1 ohm wire will be what? 1/15 meter is equal to so that means what? 0.67. Clear? So it will approximate what? 0.67 meter. Okay, 0.067 meter. 0.067 meter. So that means which option is correct? Option number B. So the answer will be option number B. So that will be the correct options. Okay, so very easy sum, clear, but also very important. This type of sums actually very often it used to come in the examination. JEE and NEET means not the tough sum will come. Clear? The concept, if you have a very good concept over the subject theoretical portion, and if you do a lot of practice, you can easily do all the sums. Clear? So and all the problems also. So now what? R by S is equal to 3/2. The ratio is given. So R is equal to 3/2 into S. So the value of S I am writing over here. So 15 ohms. Clear? So the length of the length of 1 ohm wire will be what? 1/15 meter is equal to only the normal division. Okay, 0.067. That means option number B. So option number B will be the correct option for this problem. Clear? 0.067 meter. That will be the length of the 1 ohm resistor wire. Clear? So I hope you have understood this. You can pause the video and you can also write down the solve of these problems. Clear? The solving part you can write down. Okay, if you have any doubt, any queries, you can ask me in comments. Clear? So without further delay, now let us move to the problem number 2 of today's episode. Okay students, so here it is problem number 2 of today's episode. Okay, in a potentiometer, it's a conceptual question. Clear? In a potentiometer, 10 wires are 10 wires of 10 wires. Okay, the balance point is about on 7th wire. On shift the balance point on 9th wire, we should decrease the resistance in main circuit, increase the resistance in main circuit, decrease resistance in series with the cell whose EMF is to be measured, or increase resistance in series with the cell whose EMF is to be measured. Okay. So remember, when okay, we shift the balance point to higher length, then potential gradient should be potential gradient will decrease, and the current in external circuit should decrease. So if we want to decrease the current in the external circuit, then what will happen? We have to increase the resistance in series with the cell whose EMF is to be measured. Clear? If we increase the resistance of the cell, okay, whose EMF is to be measured, then what will happen? The current flow through the external circuit will decrease. Clear? If it will decrease, then what will happen? Then the potential gradient will also decrease, and if potential gradient will decrease, then we can shift the balance point to the higher length. Clear? We can shift the balance point to the higher length. Clear? So that means what? The answer will be option number D. Okay. So I am explaining once again what is happening. So when the shift of the, if we want to, before it was 7th wire, now it is in the 9th wire. That means we are shifting, okay, the wire to the higher end. Clear? From 7 to 9. If we want to do so, then what will happen? The potential gradient will decrease. So if the potential gradient will decrease, then what will happen? The current of the external circuit needs to be what? Decreased. Okay. If the current of external circuit needs to be decreased, then what? The increase of the resistance of the resistance in series with the cell whose EMF is to be measured, or the resistance of the potentiometer wire needs to be decreased. Clear? The resistance of the potentiometer wire needs to be decreased. Clear? That means what? The option number D will be the correct option. Clear? So it is also a conceptual question. Okay. Very often it comes in the examination. So I hope if these questions will come, you can easily answer. It may be given 6th to 10th or whatever. Okay. So if the wire is shifted from lower to higher point, then this option, the resistance of the potentiometer wire should be increased. Okay. Or the last option, what? The increase in the resistance in series with the cell whose EMF is to be measured. Clear? So these options will be correct. Clear to all of you? Okay. So I hope you have understood this. Now without further delay, let us move to point number 3. Okay students, so here it is another very important numeric problem. So very often it comes. Okay, a potentiometer wire of length 200 centimeter has a resistance 20 ohms. That means this is the potentiometer wire AB. The length of this wire is 200 centimeter. Okay, and resistance is 20 ohm. It is connected in series with a resistance of 10 ohm, and the battery is 6 volt. Clear? And having a negligible internal resistance. That means we can neglect the internal resistance of this battery. Clear? Now a source of 2.4 volt is balanced against the load capital L. Clear? So this load and this voltage, it is balanced. This potentiometer is balanced. The value of L, what will be the value of L? Okay. So now see, so AB is the potentiometer wire. Okay. So what is the things? The resistance of wire AB is equal to 20 ohms given. Clear? So current through the potentiometer wire I is equal to what? V by R. Okay. So V means what? 6 volt. by R means what? These and these are in series. This resistance and resistance of this wire is in series. Okay, so resistance of this wire is 20 and this is 10. Okay, so 6 by 30. So 1 by 5 is equal to 0.2 ampere. Okay, so 0.2 ampere is the current that will flow through this wire. Okay, so voltage across AB, V is equal to what? I into R. Okay, so what is I? 0.2 into R means 20 is equal to okay 4 volt. Clear? So let potential gradient is equal to potential gradient is equal to K. Clear? Volt per semi. Okay, so length small l is equal to what? 200 centimeter given. Clear? So K is equal to what? K is equal to V by L. Okay, K is equal to V by L is equal to what is the value of V? 4 by 200. Okay, volt per centimeter. Okay, now what? Now voltage at balance condition voltage V is equal to 2.4 volt. Let length is equal to capital L. Okay, so that means what? K is equal to, now it is V dash. Okay, V dash by capital L. So that means what? L is equal to what? K is equal to V dash by capital L. So V dash by K is equal to what is the value of V dash? 2.4, and what is the value of K? 0.02. Is equal to 120 centimeter. Clear? So 120 centimeter. That means what? Option number B. So the answer will be option number B. Clear? That will be your answer. Okay. So I am explaining it once again. What is that? Okay. So here a potentiometer wire of 200 centimeter and the resistance of this wire is 20 ohms. Clear? That is connected in series with another resistor 10 ohm and a battery though which don't have any, we can neglect the internal resistance, but the voltage of the battery is 6 volt. Clear? So it is in balance condition. Okay, when the voltage of this battery is 2.4 volt. Clear? Then the potentiometer is in balance condition and this length is L. So we have to find out the length. What is the length of this L? Okay, or the length of the wire up to this point. Clear? So the resistance of the wire AB is equal to what? 20 ohms. Okay, the current through the potentiometer wire I is equal to what? V by R. So V is what? 6 volt, and R means what? The total resistance. So resistance 20 and this resistance are is in series. If this resistance will be given, then we have to add this also. Clear? But as this resistance is not given and it is given as negligible resistance, that's why the internal resistance we will not consider over here. So it is 30. So 1 by 5 equals 0.2 ampere. Clear? So 0.2 ampere current is flowing to this. Clear? Now the thing is that voltage across AB is equal to what? I into R. So what is I? 0.2 into R means what? Resistance of this wire is 20. So 4 volt. Clear? Let the potential gradient is equal to V K volt per centimeter. So length is given. Total length is 200 centimeter. So K is equal to V by L. That is the formula. K is equal to potential gradient is equal to what? Voltage by length. Okay. So what is the voltage? 4 by 200 is equal to 0.02 volt per centimeter. Okay. At balance condition, what is the voltage? 2.4. So V dash is equal to 2.4 volt. Okay, let the length is capital L, it is given. So K is equal to V dash by L, the same formula we are using. Okay, so L is equal to V dash by K. Okay, so what is the value of V dash? 2.4, and what is the value of K? 0.02. So it is coming 120 centimeter. So the value of L will be 120 centimeter. Clear? So the option number B will be correct. Okay. So very important numeric problem. You can pause the video and you can copy the sum. Okay, clear? So it's very easy, not so hard. Only you have to remember how to solve it. Clear? So hope you have understood this. So students, now here our next problem is in a potentiometer, a cell of EMF 1.5 volt gives a balanced point at 32 centimeter length. If the cell is replaced by another cell, then the balance point shifts to 65 centimeter. Okay, then the EMF of the second cell is, okay, very easy. Okay, it is very easy. So we know what? Epsilon 1 by epsilon 2 is equal to L1 by L2. Okay, here epsilon 1 is equal to what? Given 1.5 volt. Clear? L1 is given what? 32 centimeter. Clear? L2 is given what? 65 centimeter. We have to find out epsilon 2 is equal to how much. Clear? Now it's very easy. So epsilon 1 by epsilon 2 is equal to L1 by L2. Clear? Therefore L1 into epsilon 2 is equal to epsilon 1 into L2. Clear? Therefore what? Epsilon 2 is equal to epsilon 1 into L2 by L1 is equal to epsilon 1. What is the value of epsilon 1? 1.5 into what is the value of L2? 65 divided by 32. Clear? So by 64 195. Okay, 3 4. So 0 7 okay. So that means what? Approximate 3.05. So approximate 3.05. So option number A. So option will be what? Option number A will be the correct option. Okay, 3.05. Clear? So that will be the correct option. Okay. So what? In a potentiometer, question number 5. In a potentiometer, a cell of EMF 1.5 volt gives a balance point at 32 centimeter length. Another cell is replaced by this. Okay, another cell we introduced. Okay, and it is replaced by this cell, and the balance shift point is at 65 centimeter. The EMF we have to find out. So epsilon 1 by epsilon 2. Epsilon 1 means the EMF of the first cell, and that is the replaced cell. Clear? And L1 means the balance point in the first cell, and this is the balance length of the second cell. Clear? So from this equation we are putting the values of epsilon 1, L1 and L2 and finding the value of epsilon 2, which is coming 3.05. Okay, so 3.05 volt. Clear? 3.05 volt. So that will be the EMF of the second cell. Clear? Or the cell which will replace the original one. Clear? So I hope you have understood this. Now you can pause the video and you can copy the sum without further delay. Now let us move to the problem number 6. Students, here it is problem number 6 of today's episode. So 3 volt potentiometer used for the determination of internal resistance of 2.4 volt cell. The balance point of the cell is in open circuit is 75.8 centimeter when the resistor this is used in the external circuit of the cell, and the balance point shift to this centimeter 68.3 centimeter length of the potentiometer where the internal resistance of the cell. So one formula is there. So internal resistance of cell small r is equal to capital R into L1 by L2 minus 1. Clear? So very easy formula. Clear? So here capital R is equal to what? 10.2 ohms. Okay. L1 is equal to 78.5 centimeter, 75.8 centimeter. L2 is equal to 68.3 centimeter. Clear? So small r is equal to how much? Okay. So very easy. So what we can write? Small r is equal to capital R means what? 10.2 into L1 means 75.8 by 68.3 minus 1 is equal to 10.2. So 68.3 will be the LCM. তাহলে 75.8 minus 68.3. Clear? So 10.2 into 5. Okay, 7.5 by 68.3. Clear? So this and this will be cancelled. Okay. So it is what? 10.2 and 75 multiplication. Okay. So it is 765 by 683. So 765 and 683, right? 765, 683, 1, 683, 2, 1, 683. Clear? Zero. Okay. Then 2. Okay, 4. That means what? 1.12. Clear? 1.12 ohms. That will be the internal resistance. That means option number answer will be what? Option number C. Option number C will be the answer. Clear? So that is the thing. Okay. Option number 3 will be the answer. So what is the formula of internal resistance? Small r of the EMF of the battery. Small r is equal to capital R into L1 by L2 minus 1. Clear? So what is capital R is equal to the external resistance 10.2 and L1 L2 the length we know. We don't have to calculate here the voltage. Clear? It is not required over here. Okay, the voltage this one and this one voltage is not required. Clear? Now the thing is that what this formula we are using, we are putting the value of capital R L1 and L2 and we are getting the value of small r, the internal resistance of the cell. Clear? Which is coming 1.12 ohms. Okay. So hope you have understood this problem. Okay. Very easy. If you can apply the formula, then very easily it will come. Clear? It is coming 1.12. It is coming 1.12 ohms. That means option number C is correct. Okay. In this problem. Clear? So now without further delay, let us move to problem number 7. Okay. Now let us move to the question number 7. Okay. Now AB is the wire. Okay, AB is the wire, potentiometer wire with the increase, that is what? That is the variable resistance. Okay, or you can assume a rheostat. Clear? Or the variable resistance. Okay. So if we increase the value of the resistance capital R, clear? Then what? Then the balancing point J, that will shift what? Towards A, towards B. Okay, first towards B, then towards A. Okay, or remain constant. Clear? So that is the conceptual questions. Okay. So if we increase the value of the resistance, if we increase the value of resistance R, then current through potentiometer wire AB will decrease. So potential gradient will also decrease. Okay. So as a result to adjust the balance point balance point D length should be increased. So the point will move towards B. Clear? It will move towards B. Clear? So the point that means option number answer will be option number A. Clear? That will be your answer. Okay. So what is the things actually here? If it is increased, then the current through the potentiometer wire will decrease. Obviously, if the resistance increases, then current will decrease. Then what will happen? If the current is decreased, that means that what? Potential gradient will also decrease. Clear? So potential gradient will decrease. Okay. So now to adjust the null point, what? The length should be increased. Clear? So the length should be increased. So how the length can be increased? By shifting it towards B. Okay. So what? So it will move towards B. Clear? Towards the point B. So option A will be the right answer. Okay. So hope you have understood this. Clear? So if you have any queries, then write in comment, and you can pause the video and also you can copy the answer. Okay. So let us move to the next problem of today's episode, problem number 8. Students, so here it is now problem number 8. So this type of sums already we have done one in this episode. So a little bit different. Clear? So potentiometer wire of length 100 centimeter. A potentiometer wire of length 100 centimeter that you can see. This is a potentiometer wire. Okay, AC. 100 centimeter is the length. Clear? Of this wire. Okay. And the resistance of this wire is what? 10 ohms. Clear? The resistance of the wire is 10 ohm. Clear? Now it is connected in series with the external. It is connected in series with a resistance of a cell of EMF 2 volt. EMF 2 volt. Clear? And a negligible internal resistance of, that means what? We can neglect the internal resistance of this battery. Clear? The source of EMF 10 millivolt is balanced. Okay. So to balance that thing, a battery or EMF what is 10 millivolt, okay, is there. Okay. And the length, what is the length of the balancing length of the potentiometer wire is 40 centimeter. Okay. We have to find out the value of this resistance, capital R. What is the value of this resistance, capital R? Clear? Now the current through this potentiometer wire, is what? Voltage divided by total resistance. So what is the voltage? 2 volt. What is the voltage? 2 volt. And the total resistance of the wire plus resistance of the external circuit, it is capital R. So 10 plus capital R. These are in series. This is in series. Clear? So this will be what? This will be this resistance plus this resistance. Clear? That means 2 divided by 10 plus R. So potential. That is the current. Okay. That is I. That is the current. So potential difference across AC is equal to what? V is equal to I into R. Okay. That is the formula. So what is the value of I? 2 by 10 plus R. And what is the value of R? That means what? 10 ohms is the value of this wire. Okay. So 2 by 10 plus R into 10. Clear up to this? Okay. Very easy. Now the length, total length of the wire is what? 100 centimeter. So this is what? Potentiometer. This is what? Potential gradient. Potential gradient. Potential gradient. What is potential gradient? K is equal to V by L. That I have done in one sum. Okay. So what is the value of V? V means what? 2 by 10 plus R into 10. 2 by 10 plus R into 10. Okay. And L means the length. Okay. Divide by what? 100. Clear? It is the equation number 1. So we know now the value of the K or the potential gradient. Now it is in to get the balance condition, it is connected to 10 millivolt battery. Clear? And the length of the wire is 40 centimeter. Okay. So what we know? We know K is equal to what? V dash by L. Okay. So now L is equal to what? L is equal to so it is what? So now V dash is equal to what? V dash is equal to K into L. Okay. So K means what? The potential gradient into L means what? The length. Okay. The length of the balance point, that is 40. Okay. So now what is the value of V? 10 into 10 to the minus 3. Okay. Is equal to what is the value of K from 1? This is the value of K, 2 by 10 plus R into what? 10 by 100. into 10 by 100 into what? Into it is 40. So it is what? It is 40. So that means what? 40 by 100. Clear? So by here we calculating, after calculating, clear, we are getting the value of capital R is equal to what? 790 ohms. Clear? The capital R, value of capital R will be 790 ohms. Okay, it will be 400. Okay, it will be 400 by 100. Okay, so it will be what? 790 ohms. Okay, so that will be what? That will be the answer of this problem. Clear? So option number which is correct? So here option number A. Option number A will be, that is the answer. Option number A will be correct. Okay, 790 ohms. Clear? So very easy. This type of sums already we have done. Okay, one in this episode only. Clear? If you can remember, it was problem number 4. We have done this. Clear? Again in problem number 8, a little bit different. We have done. Clear? So the 790 will be your answer. So here we have to find out the potential gradient, and from there we have to find out the external resistance capital R. Clear? So hope you have understood this. Okay. Now without further delay, let us move to the problem number 9. Okay students, so here it is a conceptual questions. Clear? So consider a current carrying wire I is in the shape of a circle. Note that it is a current carrying I, it is the shape of a circle. Okay. So the current I is flowing. Suppose current I is flowing through it. Okay. Note that the current progresses along the wire. The direction of J means current density. Okay, changes in the exact manner while the current I remains unaffected. Okay, so what is that? The J means what? Current density. So current density will move towards the movement of positive charge and the electric field produced by charges, the positive charge due to the electric field produced by the charges accumulated at the outer surface. Okay, so which option is correct? Option number B. Clear? So answer will be what? Option number B. Option number B will be the correct options. Clear? So the current density will move towards the, or depends on the movement of the positive charges. Clear? And the positive charge will be developed due to the electric field produced, okay, by the charge accumulated at the outer surface. Okay, so that is the answer. B will be the correct options of this question. Okay, so hope you have understood. Our answer will be option B, electric field produced by charges accumulation. Okay, accumulation the surface of wire. Okay, so that will be the answer of this question. Clear? Now let us move to the last but not the least, the question number 10 of today's episode. So students, here the last problem of today's episode, last but not the least, problem number 10. A resistance capital R is to be measured using a meter bridge. Student chooses the standard resistance capital S to be 100 ohms. Okay, the value of capital S is what? 100 ohms. Okay, he finds the null point, the L1 is given 2.9 centimeter. He is told to attempt to improve accuracy. Which of the following is a useful way? He should measure L1 more accurately. He should change S to 1000 ohm and repeat the experiment. He should change S to 3 ohms and repeat the experiment. He should give up hope of a more accurate measurement with a meter bridge. That means he cannot use a more accurate measurement with a meter bridge. So he should give up. Clear? So what we know? Clear? We know R by S is equal to what? L1 by L1 minus 100. Okay. So R is equal to what? S into L1 by L1 minus 100. Clear? So what is the value of S? Okay. So what is the S to be 100, okay, so 100, clear, into what, L1 2.9 divided by what, 100 minus L1, 100 minus L1, okay, divided by 100 minus L1, so 100 minus L1 means what, 2.9, clear, so it means what, it means 290 divided by okay 91.7, so this, okay, so 2900 971, okay, three, two, okay, 4, 9, okay, so that means what, approximate 3 ohms, clear, so the value of R will be approximate what, 3 ohms, that means what, the S, what, he should change S to 3 ohms, clear, and repeat the experiment, okay, so option number C will be correct, clear, option number C will be correct, clear, so he should change S to 3 ohm and repeat the experiment, clear. So now what we know, R by S is equal to L1 by 100 minus L1, so R is equal to S into L1 by 100 minus L1, clear, value of S is 100, clear, it is given, okay, 2 minus L1 means what, 2.9 by 100 minus 2.9, so it is coming 2.9 means almost 3 ohms, clear, so he should change S to 3 ohms and repeat the experiment, clear, to get the accurate result. So student, hope you have understood all the problems today. All the problems are very important, clear, so you have to practice it as much as you can, okay, and also see my other episode on the particular topic, clear, that I will upload in Physics Scholar or Coursera, okay, so to clear your concept, that are also important, and these are content for only the students who will appear for the JEE main and advanced and as well as the NEET examination, clear. So wait for my next episode, so I will upload much more interesting topic, clear, on MCQ, okay, on different chapters, okay, so continue watching, okay, thank you for watching this.